Hi everybody, welcome to the Noark training session. We were just waiting for the last number of stragglers to come in, but we've got quite a lot to get through, so I'm just going to kick it off. I'll turn off my camera once we get started. And just to explain what this is just going to be a broad commissioning guide for Noark inverters. It applies to the single and the three-phase and for parallel installations. And I'm going to be assuming mostly people are using managed batteries, but we will touch on lead acid type applications as well. All right, we'll kick it off. So to start off with the main features of the Noark inverters, if you're not familiar with them, they're a hybrid inverter, which means they've got a solar input and an inverter charger as well. So they'll take energy from the grid or from a generator and charge the battery. They'll take energy from a battery and provide AC, and they'll take energy from a solar panel and either charge a battery, supply AC to loads, or they'll also export to the grid as well. So the nifty all-in-one unit. You can use them for managed and unmanaged batteries. They have a great online portal. They come in single-phase and three-phase models, and they can be used in parallel. They're mainly designed for on-grid, but they're suitable for off-grid as well. We've got quite a few people using them for off-grid, as they're a really nice, quick, easy installation for an off-grid system, and they're affordable. I haven't got a bullet point about this, but it's a transformerless inverter, as opposed to your Selectronics or your Victrons, which have a nice big transformer in them. So they don't have the surge capabilities of those style inverters, which you pay a lot more for. Even though it does have a surge rating in the spec sheet, it's really got nowhere near as much as, in practical terms, as a Selectronic or a Victron. And that's because it doesn't have a great big transformer in it with henries stored in it, which gives you that surge capability. So you just have to factor that into your design. So out of the box, you're going to have an inverter, a wall mounting bracket, some bolts, mounting screws, communication cables, an Allen key, the manual, a Wi-Fi dongle, battery temperature sensor, and a CT. In terms of where you can install this inverter, the clearances around it are 500 millimeters top, bottom, and to the sides, and then 1,000 millimeters clearance in front of it. It's an IP65 rated inverter, so you can install it inside or outside, which is great, makes things nice and flexible. It has a mounting bracket, looks like this. Basically, you just bolt that onto the wall, and then the inverter just drops down into that mounting bracket, and then you fix it with 2 screws either side, and that's all you need to do. So it's a nice, quick physical installation of the inverter. I'm not going to cover where you can and can't install it. I'll assume that you're familiar with the standards for that. Obviously, you're going to have to reference the normal PV installation standards, and then if you've got batteries, you're going to have to reference the battery standard as well. In terms of the wiring, here's a nice, simple explanation of the DC wiring. We've got, this is with a Discover battery system. So that has an external BMS, but like a BYD does. And so we've got 4 batteries going to a bus bar. This is a Lynx power in, which is a good choice. Then going to our main isolator, and then into the Noark. And then the comms cables from the Discover batteries, the days chain together, then into the Link 2, which is the BMS, and then from the Link 2 into the Noark. And I'll show you exactly where that connects in some future slides. It's got a PV input. Different models have different numbers of MPPT trackers. They have MC4 connections on the outside of the inverter. And then it has 3 AC connections. It has a grid input. It has a load or an output, if you like. And then it has a generator or auxiliary AC input as well. In terms of the battery connection, you're going to take the front panel off the inverter here, go up in through your glands, and we've just got 2 little connection points here and here for your positive and negative. For your battery comms wiring, there's an RJ45 plug inside behind this front plate. It's different on different models. So on the single phase models, it says RS485/CAN, and it's in the top left. With the 3-phase model, it has one that's labeled BMS. And for those who are interested, if you ever wanted to talk to the inverter via Modbus RTU, that's done over the RS485 and RS485 style connection. You can actually have the CAN bus and a Modbus connection on the same RJ45 plug. You just have to split out the cable because they're on different pins. Oops. If anybody has any questions, just put them in the messages. The AC wiring on the single phase, it looks like what we've got on the left-hand side here. So you've got the auxiliary or the generator port on the far left. Then you've got the load or the output in the middle here, and then the grid input on the far right here. In the 3-phase, it's a little bit more confusing. You've got the grid input on the left-hand side here, and then the load and the auxiliary input are stacked on top of each other like this. So the load is the top level, and the auxiliary or generator port is the bottom level there. As far as the PV wiring goes, it does have an isolator built into it, but it says in the manual you need to use an external isolator. And then depending on what state you're in, you'll probably need one up on the roof as well. You need to work within the PV voltage range of the inverter, just like you do with any inverter. You'll need to work within those voltage parameters. And you can see there's different numbers of trackers. So the 3.6, the 5, and the 6 in the single phase both have 2 trackers and 2 sets of inputs. And then on the 3-phase, there's also 2 trackers as well. For the CT connection, so it comes with a CT. For the single phase inverter, you can see that there is a set of push-in connectors on the main board here. And your CT is going to go into, each one of these has a number, and your CT is going to go into numbers 3 and 4. And you just push those in, and then you're going to put that CT around the active from the grid. And the arrow on the CT should be pointing towards the inverter. So it comes with that CT in the box. Do you know how long the cable is, David?
I think it's a 3-meter cable.
Yeah, okay, pretty good. Instead of using the supplied CT, you can use a meter. And so that's going to go back to an RJ45 plug on the main board here called meter. And there's a little wiring diagram for that here. So if you want to have that in the main switchboard and have the inverter somewhere else, for instance, then you might use the meter. And the three-phase equivalent of all of this, three-phase inverters can come with 3 CTs, and they have their assignments and these push-in connectors, channels 3 and 4, 5 and 6, and 7 and 8. That's for L1, L2, and L3.
We'll just see if we can get the mouse working on the screen.
Oh, it's not coming up?
No, it was earlier. It's just,
Is it doing it now?
it is now.
Yep.
I think if you move
Okay.
off the other screen.
Yep. Okay. So this is where the CTs attach in here. Just push them in. And then obviously they're going around each of your three-phase actives. And again, with the arrow pointing towards the inverter. If you don't want to use the CTs, again, you can use a three-phase meter. And that gets connected to the meter port.
We've probably got those Carlo Cavazzi ones.
Do it. Okay.
The Victron Carlo Cavazzi will probably work.
There isn't a Chint, there isn't a Noark one as well?
We can follow that one up. Yep.
Yep. Okay. Then there's a chassis earth that needs to be connected as well. It has a generator 2-wire auto start function built into it. On the single phase, that goes to pins 5 and 6. It's just a dry contact. There's no voltage on it. And then, oops, 2-wire auto start. And then for the 3-phase 2-wire auto start, it's just on pins 1 and 2 on the second row. All of this is in the manual. There's a DRM plug. And I'll talk about this a little bit more when we're going through the commissioning software steps. But basically, you don't need to use it unless you're doing DRM in Queensland, unless you're using a GSD device. You need to have DRM switched off if you're not using it. Otherwise, it's going to throw an error. It does come with a little plug. And every now and again, you need to put that little plug in, even if you're not using it, according to the guys at Noark. But I haven't had anybody have that experience so far. It's a little terminator plug. So for the commissioning, there is an app which you can use to connect to the Wi-Fi, but they've been having some issues with it. There's a new one coming out very soon. And so at the moment, you do it what's the long way, which is you have the inverter switched on and the dongle will fire up and you connect to it with either your phone or with your laptop and go to your Wi-Fi menu, and you'll be able to see this Wi-Fi network here starts with USR. There'll be no password, and you just connect to that. And then you go open any browser and just go to this IP address, 192.168.1.1, and press enter. So you could use Google Chrome, Edge, Safari, whatever your normal browser would be. And you just put that in like it's a website URL. Again, this will only work if you're connected to the Wi-Fi network of the dongle. Once you're in there, it's going to bring up this page, and it's going to ask you for a username and password. Just admin, then chint1877 global. I'll send you this guide after the presentation as well. So you've got all of this. Once you're logged in, you need to go to the Wi-Fi menu and change it. It will come default as AP, which means access point, and we want to change it to AP STA, which means access point and station. And then you want to hit the search button, and then the Wi-Fi networks in your area will come up. And so the customer's Wi-Fi that you want to connect to, you select that there. So in this case, it's got Noark Starlink. Then you hit save. It'll take you through to this page. And then when you put the Wi-Fi password in, hit save. And then it will say, do you want to restart? And you press restart. Once that's done, the dongle will restart and it will connect to the Wi-Fi network that you have selected, and it should be all good from that point on. The Wi-Fi dongle should have a green light on the link indicator and a red light on the COM indicator. After that, you need to go to the Noark portal and you need to create an account if you haven't already created an account. If you're an installer, it's going to need to be an installer account, and you're going to need to register the system by putting in its serial number of the Wi-Fi dongle and of the inverter. Once you're in there, once you've done that, it's going to ask you for the address and the NMI of the customer, and that's going to generate the LFDI, which is needed for the backstop in Victoria. And once you've got that LFDI, you can then go to your DNSP's portal to do the export capability test. There's going to be a guide, because it's all a bit new. There's going to be a guide coming out from Noark on this shortly as well, but I'm sure most of you will be familiar with that, with the other installs you've been doing of a similar process. So you don't need a third-party piece of kit to do it with Noark. The Wi-Fi dongle that it has built into it does the backstop for you. So on your main screen, once your inverter's switched on, you've got this LTD screen, and you can click on these various icons we've got here. So we click on the solar one, we'll see what the different MPPT trackers and of the solar array are doing there. You click on the grid, we can see what's happening with the grid. Click on the loads, we can see what's happening, what power is going to the loads. And click on the battery, and that will give us the state of charge of the battery. And if it's a managed system, you can click on this little corner LIBMS down here, and then it will show you actually what data is being sent to the inverter from the BMS. And then if you click in the middle, which is less obvious, it gives you the general inverter information. Click this cog in the top right-hand corner for settings. So this commissioning guide, there's a fair bit to get through. So I'm going to give you a tour of the menus, and then I'm going to sort of go through the main little issues that I've encountered for people so far. And then if I have time at the end, I'll give you a quick example, but I don't think I'm going to have time for that. I find that the menu structure is not particularly intuitive. It's designed for an on-grid load shifting type setup, but you can use it for off-grid. But because it's designed for this on-grid load shifting scenario, the terminology is all kind of geared towards that. And so it takes a little bit of interpretation when you're setting it up for off-grid. But once you understand it, it's all fine. It's just sort of the way it's labeled, I guess. So the first menu you've got is the device info menu. You don't really need to do anything with this. This is just going to give you alarm codes if you ever have any errors. It tells you the LCD version, the control board firmware version. This is the least important one for us at the moment. The main one was got the system setup page. So I should have had that previous slide, should have come after the slide. So you click, when you click that cog in the top right hand corner, you'll come through to here. If you click device info, you'll go through to there. So if we go to basic settings, this is where you're going to set up the time of the inverter. The rest of the stuff doesn't matter too much, but the really important one on here is lock out all changes. So if you have that on, then every time you're going to need to make a change, you need to come and turn that off. And the default password for that is 4 sevens. The one I have in the office here doesn't have that on. And when I went to help somebody do commissioning on one recently, it was on. And we had to do it sort of every 30 seconds. We had to go and turn it off. After that, we have the battery settings. So this is the first page of the battery menu. There's lithium mode, battery voltage, battery percentage, and no battery mode. Lithium mode is basically CAN bus. So you only use that if you're using a managed battery, such as a Discover, a Pylon Tech, a BYD, anything that's got a CAN bus connection that's compatible with a Noark. There's a list on the website of compatible batteries. You would choose that. You still need to set the battery capacity and max charge and discharge current over here. Activate battery is something you can turn on to recover an over discharged, I think, I've written that wrong, battery. And disable float, it's probably a good idea to have that on so the charger doesn't try and hold the voltage at the top set point, even when the BMS is requesting 0 current. If you're using something like a Discover battery, it wouldn't be as much of a problem because they actually are changing the voltage in their request from the BMS through to the inverter. So once they go through their absorption cycle, they'll then request a lower voltage anyway. But other BMSs might not be as dynamic as that, and they might still broadcast that top voltage even at the end of the charge cycle and just request a 0 current. So it's a good idea to have stable float charge on for lithium batteries. If you're not using a managed battery, you're going to want to have it on battery voltage or battery percentage. When I've been doing it here in the office with some Power Plus batteries, I've been using battery voltage, and that works very well. Welcome, Josh Shepherd. You haven't missed too much, Josh. After we've done the first battery setting chat page, by the way, this little tick button down the bottom here, you've got to tick that before you move on. Otherwise, it won't save your changes. That's a really easy mistake to make. We're then going to press this down arrow here. We're going to go on to the next battery page. And you've got some settings here, which I find slightly confusing to begin with. So we've got on the left-hand side, you've got the gen charge settings, and on the right-hand side, you've got the grid charge settings. So the gen charge setting, the start value, that's the percentage that the battery will need to be for the generator to turn on. And then the current limits the amount of current when charging from the generator. Gen charge needs to be enabled for that to happen, and gen signal needs to be enabled if you want to use the 2-wire auto start functionality. On the right-hand side here, you've got the grid charge section. According to the manual, grid start percentage has no use. And this value here, again, is going to limit the amount of current when charging from the grid. These values are expressed as a percentage here, but I think it actually depends on whether you've used battery percentage or battery voltage. If you're using normal lithium managed battery, which I think most of you will be doing, then it's going to be expressed as a percentage here, or if you're using battery percentage. But if you're using battery voltage, then it would be expressed as a voltage in these two windows here. Apparently people are sitting in the waiting room. Sorry, everybody, won't be a second. Right. Once you've saved those settings, press the down arrow again. You're going to go through to the battery settings, page number 3. If you're using unmanaged batteries, this is where you're going to set all your battery charge voltages, equalization settings. So you're just going to set them according to the battery manufacturer's instructions. Not needed for managed batteries. You'll see a different page for managed batteries, which I'll show you in a second. And then this shutdown section here, that's just the same as it is on any other inverter. So shutdown value is when the inverter is going to shut down. So if it gets below 20% state of charge, in this example, it's going to shut down. A low bat, that's the alarm. So it's going to start giving alarms to the system. When it gets to 35, then it's going to shut down at 20. And then the restart value is once it starts charging up again, when is it going to supply the AC loads again? Well, it's not going to turn them on again until it gets to 50% in this example. If you're using a managed battery, instead of seeing that previous page, you can see this page. It's pretty much exactly the same, except it doesn't have all those values for the charge voltages. The next menu we're going to look at is the grid setup menu. There's a note in the manual here which says if you checked all your physical connections, turn on the AC breaker, turn on the DC circuit breaker on the PV strings and battery, turn on the circuit breaker on the battery pack, turn on the DC switch on the inverter. So in grid settings, you have the grid mode settings here, and you're basically going to be selecting between Australia A, Australia B, and Australia C. You'll need to check with your DNSP which one of them applies to you. But most of you probably will know that from installing other inverters. I think we're Australia A here, aren't we, David?
I'm not sure.
Yeah, that's what the one in the office had said to me. Once you've done that, it's going to pre-fill all of these pages. So I'm just going to go through these pages pretty quickly, but you shouldn't really need to edit these. You could, perhaps if you're off-grid, you might change some of these, like the reconnection time, but I'd suggest that you leave them all as standard most of the time. This page is just the trip times for various different voltages and frequencies. You might want to modify these for use with generators, or perhaps if you were using it in an AC coupled scenario, if this was the slave. But I don't think that's not a likely scenario for most of you. If you do want to do something like that, have a chat to us and we'll talk to the guys at Noark to get you any information you need on doing that. Again, this is frequency shift response settings, volt bar settings, and then we get through to generator port usage. So on here, we've got generator input rated power. This is the max power allowed from the generator. So it won't draw any more than the value we've got in here. This is obviously going to be affected by the maximum charge and discharge values that we've already put in the battery settings. It's going to go off whatever the lowest value is for that. There's also a peak lopping function. So if you enable that in a later menu, which I'll show you, then if it exceeds this generator input rated power value, then it will start drawing from the batteries to compensate so it doesn't go over this value. Again, connected to grid input. That's this one here. That's basically if you decide for whatever reason to wire the generator into the grid input instead of the generator input, perhaps you might want to use the generator input as a smart load. Then you need to tick this box here. It's still going to limit the charge from that same set of contacts, though, according to what you've put under the grid settings in the battery menu. Does that make sense? Does that make sense to you, David?
Mm-hmm.
Yep. Okay. So even though you've told it that the generator is on the grid input, when you're changing that maximum grid charge current value in the battery settings, you need to change it on grid, not on generator. Smart load output. So use the generator input connection as an output, which only receives power when the battery state of charge and PV power is above a user programmable threshold. So it's basically saying this is it's like AC out 2 on a Victron, perhaps. You can set some conditions for an AC output to be on or off. So the example that we've got here is you set power to 500, on to 100%, and off to 95%. And that means that when the PV power is greater than 500 watts and the battery state of charge is 100%, it will turn the smart load on. When the battery falls below 95 or the PV power falls below 500, then the smart load will switch off.
Flat heating or some sort of dump load.
Yeah. Pump, maybe. Any questions on that? Oh, okay. Advanced function menu. Solar arc fault on. I don't know what that is. It just says for the US only. System self-check, again for the factory only, don't worry about that. DRM, this is an important one. This comes switched on as standard, I think. And so if you're not using it, if you're not in Queensland, you need to switch that off, otherwise the inverter won't turn on. The only DRM that it does, as far as I know at the moment, is DRM 0, which means when the grid wants requests to the system to throttle the power, it will just throttle it all the way down to 0. But I think that's going to be changing in the future.
And DRM is demand response.
Demand response mode, yeah. Signal island mode. So there's a port on it called the ATS port. And so if you have signal island mode switched on, then when the inverter is not connected to the grid, there will be 230 on the ATS port, which is one of those small connectors like where the CTs are going into. And when the grid is connected, there'll be 0 volts on that. So you could use that if you wanted to have a dynamic neutral and earth link.
Do you mean when the grid is available? So if the grid's there,
yeah,
compared to when the grid is unavailable, the grid goes out.
When I've tested it, it seems to be when it's synced to it. So it's not just going to do it when it notices there's voltage there. When it synchronizes with the grid, it will then engage that. Because I was looking at it, wondering if it could be used for an external bypass relay, so you could connect the input to the output like you can on a Cellectronic or a Victron. But it seems like you might be able to do that, but there's no information from Noark saying that it 100% works that way. So you can't use it for that at the moment because it's not guaranteed. It just seems to work that way, but it's not guaranteed to only be on when the AC synchronization is complete. BMS earth stop, this is another important one. So when active, the inverter will go into fault mode when BMS comms are lost. Otherwise, it will continue with the last instruction. So what that means is if you pull the BMS cable out of the inverter, if you don't have this on, it will just keep going, but it will just assume whatever the BMS last told it to. So if it said keep charging, it will just keep charging. If you have this switched on and you pull the cable out, it will then go into error and switch off. It sounds like you might not want that because you might want it to continue in unmanaged mode, but it's not what it's set up for because it doesn't have fallback voltage settings. It's just going to keep going. So you want to have BMS error stop switched on. It might be in a future firmware, they will offer a setup where if it loses comms, it will fall back to some voltage-based settings, like you can sometimes do on Victron, but at the moment it's like Cellectronic. You just want it to turn off when it loses comms. Backup delay before power is provided to loads after grid is lost. Not sure why you'd want to do that, but if you want to, that's there. Generator peak shaving, we spoke about that before. If you want to do that, you switch that on. And so in the example we had, the generator was 8,000 watts. So if you, obviously you've got to have an inverter which is rated for that. But if you were drawing 8,200, it would draw 8,000 from the generator and then draw 200 watts from the batteries. CT ratio, self-explanatory, I think. CEI 021 report. Do you know what that is, David?
No.
No, I don't think you need to worry about that. Third page of advanced functions. This is just where you're going to set up your meters and your parallel setups. So if you're wanting to do three-phase, there's no option to have three of these inverters set up, three single-phase inverters set up in a three-phase arrangement like you would with Selectronic. You would just get a three-phase model. And so then if you need to have a larger system than any of the three-phase models offer, then you would use multiple three-phase inverters in parallel. Or if you have a single-phase setup and you need something bigger than any of the single-phase models, you're going to put them in parallel. So you're going to tick this parallel button here. You're going to select one of them as being the master, and then the other ones are going to be the slaves. If you're using an external meter, you're going to tick this box, external meter for CT, and then you're going to select the meters on the right-hand side here. The last page, advanced function, ATS. If you want to use that signal island port that we discussed before, you have to turn it on here. Low noise mode, I'm not 100% sure what that is. Do you know what that is, David?
No, maybe it's just it regulates the fan. Maybe it's just minimizes fan operation.
Oh, yeah. Okay, so this is probably the hairiest part of the system, which is why I've left it to last. Before I do that, I'll just check if anybody's got any questions. Comment from Pedro. Backup delay, maybe to let end user know the grid is down. Yep, could be.
And maybe it just doesn't, so it doesn't rush to supply the load. So all of a sudden,
yeah,
what was coming from the grid, bang, it's got to come from the batteries that might bring it in slowly.
Yep. So the system work mode is basically where you're going to set how the inverter manages the power flows from the PV input, the generator input, the grid input, from the battery to the loads. And it's, like I said before, it's set up for this on-grid load shifting type mentality, but you can use it for off-grid. It's just it doesn't use the normal terminology that would be used in off-grid inverters. So this first tick box we've got in the top left-hand corner, you can choose between these three different modes. Selling first, zero export to load, and zero export to CT. So selling first, if you're in this mode, then excess solar power will be sold to the grid. If you have a function called time of use, which I'm going to explain in a moment, if you have time of use enabled, you can also export battery power as well. So you would use that, for instance, if you wanted to export battery power at night. So you charge your batteries up during the day, and then in the evening, you might discharge your batteries at night just to make some money. Or if you didn't have a meter in the main switchboard for some strange reason, you might set a small amount of export to cover what your loads are during the evening. The power source priority for time of use is solar panels first. So the load will take power from the solar panels first, then the grid, and then the batteries, depending on the programmable percentage of discharge, which we'll see in the time of use section. power is only provided to the load terminal. Sorry. If we then go to zero export to load, then that means that power will only be provided to the load terminal. It won't sell to the grid at all. If you have zero export to CT, power is connected to anything on the home side of the CT or meter. So what that means is that depending on where you've got your CT or your meter, it will basically be in a zero export type scenario. So it will provide power out through the grid connection of the inverter, but at the point where the CT is, it's going to try and keep that to be zero. So if you have some loads in between the CT and the inverter, say they're drawing 500 watts, it will allow 500 watts to go through to the grid connection on the of the inverter, but but they're going to go straight into the loads, so the current value that the CT is seeing is zero. So it's going to try and keep that to zero. This is how most export limitation devices work for inverters. Usually, I think you do that with a meter because the CT is a bit short. You say 3 meters?
Yeah.
It depends. If the inverter's right next to your main switchboard, then it might be all right. But this is a good function because it means that you don't have to run all of your loads in series with the inverter through the load terminal. It means you could potentially not use the load terminal at all in a domestic grid-tied load shifting scenario. You would just have one connection back to the main switchboard through the grid from the grid terminals of the inverter, and you have that meter in the main switchboard, and that allows it to monitor what's happening. This next value, solar cell, is slightly confusing. Solar cell, when that's enabled, it means that it can sell solar once there is an excess. That's what the manual says. David's just left the room. I was going to wait for him to come back. Just going to ask him a question. David, are you clear on when you have zero export to load, but you also have solar cell enabled? The manual says when enabled, excess solar is sold. So does that mean that it will export some to the network depending on
if the battery's full?
Yeah.
If the battery's not full,
yeah,
my guess is it would limit that.
Yeah, it just changes the priorities.
Yeah.
So the naming conventions are very confusing. The max cell power, well, that's as it sounds, that's just the maximum that it will ever actually sell to the grid. Zero export power is a calibration to ensure there's no export to the grid. So you might set that so that to 20 or something like that. And the reason for doing that is that if you want it to be 100% zero export, when you're on zero export, it will actually stop the inverter if you start feeding into the grid. So you can have this little sort of offset value here, which is zero export, but pulling in a little bit to give you a little bit of buffer so you don't accidentally go over and get charged by your DNSP. And grid peak shaving, this is the same as the generator concept. So you can set it so that you never draw more than a certain amount from the electricity grid. If you do start drawing more than that, it will supplement from the inverter. Now we come through to the system work mode, time of use. So this is a menu where it divides the day into a series of segments. You can change these segments, these time segments, starting at, that's 1 a.m. to 5 a.m., 5 a.m. to 9. You can click on those and use the up and down arrows on the front of the inverter to change those. The column on the left-hand side is grid charge. And so if that's enabled, during that selected period, it will allow charge from the electricity grid in that period. The same with the gen column. if you have that ticked for whatever time period you've ticked it, it will allow generator charge in that period. So if you're in an off-grid scenario and you didn't want the generator to start at night, you could perhaps have a time period set for the evening where you have the generator unticked. The power determines the max discharge of the battery during this time segment for selling to the grid. And then the batch column, if the voltage or state of charge, so you'll either have in this column here, the bat column, if you're using managed batteries, you'll see a percentage here instead of voltages. So if the voltage or state of charge falls below this value, it will charge from the grid or the generator if these are available, and it will charge up to the bat set value. So if I have it set, so if say it's between 9 and 1 o'clock, and I have grid charge enabled, if I fall below 50.9, then it will charge back up to 50.9. So when it might do that in quite a dramatic way is say that set point is quite different in the time period beforehand. So say between 5 and 9, it was, it got down quite low, and then suddenly you kick on over to this time period when grid charge is enabled, then suddenly it'll go, okay, grid charge is enabled, I'm going to charge up to 50.9. I might have been down to something much lower in that time period where there was no grid charge. And in the same way, if you get quite a lot higher than this, then it will sell battery power to the grid, provided that selling first is enabled on the previous page. So the way I've got one set up here in the office is that I have selling to the grid enabled in the evening, and so I sell, and I have a very low value, and that's because I don't have a meter in the main switchboard, and so I just sell during the evening at a very low rate, just to offset whatever the office running power is when nobody's here, because during the day we're covered by the main solar. And so I sell to the grid in the evening, and I manage it from this little menu here. And then the third page after this is system work mode, and it just has these days for which the time of use is enabled. So you can have everything set up in this menu here, but say on Sunday, it won't use that. And so if you don't have time of use enabled, it's just going to behave according to the standard values that you've got set up in your battery charge settings. So if we go back through those again, just to make this clear, if you don't have that set up, it's only going to start charging from the generator when it gets down to 30%. And it will just charge all the way up to 100%. But if you have time of use enabled, it will charge up to whatever you've got that set value for that time period being. So instead of charging up to 100%, it will charge up to whatever you've got as a battery voltage or percentage in time of use.
We've just had the Cash has just responded on the lengths of those CT. The CTs have got around a 5 metre long cable.
Oh.
The energy meters, and they can be extended to 30 metres. The CTs, energy meter CTs, are about 1 metre long, but can also be extended.
Okay.
Depending on where the switchboard is. Thanks, Cash.
Okay. So just going to get rid of that for a moment. Sorry, got a problem with my slide here. So this is just the main takeaways. So we're pretty much out of time, but just the main takeaways that I have with my experience with these inverters so far is the DRM. You've got to switch that off unless you're using a GSD device. Check something in there. The battery error stop, make sure that's switched on when you're using a managed battery. the other thing is that when you first turn it on and set the system up, the inverter just takes a minute to start actually putting out power. So you'll sort of set everything up and there'll be no power on the output, and you'll be wondering if there's, if you've done something wrong. But actually just sort of takes a little bit of time. And if you click on, I showed you at the beginning on the LCD screen, if you just click on the load output of that, you'll see the voltage climbing up. And then once it sort of gets to the full AC voltage, it'll then wait a little bit longer and then it will engage. That system lockout password, 4 sevens. That's an easy one to get confused about. Time of use. If you need help with that, just give us a call or send us an email. It can be quite confusing. If you switch the generator to the grid input, the LCD display will not change, nor will the settings for the generator auto start relay. So you still set the generator auto start relay in the same place. And when you're looking at the power flows on the screen, it's still gonna, if you've got the generator on the grid input, it will show power coming in from the grid. And if you've got the generator on the generator input, then it will show it that way, even if you've ticked that box saying that the generator is on the grid input. And then the relationship between the grid and generator max power and battery max charge current. So all of these values are going to influence each other. And this is especially for like an off-grid type application. The comment from Derek as well, that all of these settings can be changed via the portal once you've connected it as well. So you can change every single setting remotely, which is a huge help. If you have a customer who's a long drive away and you don't want to go to site and you need to change something, you can just do it all from the portal. But so if we look at these menus here, in the gen port use menu, we've got the generator input rated power. So that's set to 8,000 watts. So it's not going to draw any more than 8,000 watts from the generator. Then in the battery settings, we've got the maximum battery charge and discharge values. So it's not going to draw more than 8,000 watts, but if the value you have set here, say it's only charging the battery, for instance, then if you've got 40 amps, then it's only going to draw 2,000 watts from the generator because it's bottlenecked by that. But then if you turn a load on, that would go up. If you have a CAN bus connection, you can still set the maximum charge and discharge values. But if the CAN bus requests a lower current rating, then it will go by that. It's always going to take the lowest value. And then on battery setting page number 2, you've also got a limit to the amount of current that can come from the generator or the grid as well. So that's all of these are going to work together. And then finally, we've got the system work mode down the bottom here. And again, that's going to change how much power or what it's going to charge something up to, depending on what you've got set for the system work mode. That's most of what I wanted to cover today, and we're bang on time, which is good.
I guess if anybody wanted to give us a buzz and have a look at a demo site, we've got the DPA site. If you download the My Noark app,
yep,
we can give you the logins, so you can have a look at what a real-life system looks like.
Yeah, this is the first time doing this webinar and this slide deck, so I am going to be doing it again, probably in a month's time or something like that. I'll add a bit more information on the Noark portal to it, and I'll keep running it periodically. And so if anybody has anything they want me to cover or anything like that, please just let me know, and it will just evolve over time. I'll make the slide deck available, and I'll just quickly go through. I've got a quick little example here of a Noark system paired with a Discover battery. So this is with 2 Discover batteries, so they're 200 amp hours, Set it to lithium because it's a managed setup. Max charge rate is 135 amps. It's an excerpt from the manual. We've set our shutdown at 10%, low battery warning at 40%, our restart at, low battery at 20 and our restart at 40. And then we've set the unmanaged voltage settings in here as well. But you don't normally need to do that because I don't think it falls back to them. This is an example if you were going to do it as unmanaged. Then we've got BMS earth stop on. We've got DRM off because we don't need it in the area that we're in. Yeah, and that's the basic setup for a Discover battery. So I'll send out the slide deck at the end of this. Thanks everybody for coming along. If you've got any questions, send us an email or put them in the chat right now as your last chance.
Thanks, Gareth. Thanks, everybody.
All right. Okay. See you later, everybody.